LRO is the Lunar Reconnaissance Orbiter, which is a NASA satellite that's up orbiting around the moon right now. They have a laser altimeter and they're getting digital elevation maps. So they put together a mosaic of basically the whole moon from different wide angle camera images. And we've taken that mosaic and put it onto that 3D model.
So after we downloaded all the data from NASA, we feed it into this program called OSG. And what that does is it builds at varying levels, at varying scales, zoomed out previews per se of the lunar surface.
As you zoom in on the moon, it pulls up higher and higher resolution data. It's up to 0.5 meter per pixel. The Lunar Reconnaissance Orbiter imagery is just a lot more detailed than what was available before. This model, when it's built, comes out to 184 gigabytes or something like that of data.
What the high resolution data in this model adds is it allows you to zoom in way close to the surface and actually trace out and look over hills and valleys, and you feel as if you're actually on the surface of the moon. At this level of detail, you can see skylights, you can see lava tubes, you can see craters, individual craters, and you can even guess how old some of these craters are just by how finely defined the outlines are. So the ones that are more rounded, the ones that are more blurred out are the older craters. The ones that are sharper and more refined are typically the newer craters, just because they're fresh, they're new, and they haven't had hundreds and hundreds of years of micrometeorites chipping away at their edges.
With this higher resolution data, we can see some really interesting features on the moon, like lunar lava tubes or the collapsed lava tubes. So these were formed back when the moon was volcanic many, many, many years ago. And the lava cooled, this central part kept flowing and the external part cooled, leaving a tube behind. And we believe there's actually some of these lava tubes that are still underground subterranean caverns. And that's a really interesting area on the moon to explore. This data is a wonderful resource, and in being able to put it together in this kind of a model just gives us an unprecedented look at what the moon will be like. As we prepare for our mission, we will use this high-resolution data in simulation so we can actually fly over the moon and see what our cameras might see on the moon. It's a very cool thing to play around with. I know several of us have spent hours looking at the moon, exploring different areas that we hadn't seen in detail before.